This is AP Calculus 3.3, Rules of Differentiation, page 3. All right, we are starting right here, and remember this notation. It's saying find the derivative of this mess inside of here. That's what this means. This is telling you to find the derivative of that mess inside the parentheses, which is a quotient rule because we're dividing here. So let's see, bottom. So this derivative, so we got to run through a quotient rule here. Bottom, x minus 2 times the derivative of the top. The derivative of that 4 is gone. The derivative of this negative 3x is a minus 3. And the derivative of a minus x squared is minus 2x. So here's bottom, derivative of the top minus the top, 4 minus 3x minus x squared times the derivative of the bottom, which is 1, all over the bottom x minus 2 squared. All right, now we have to simplify this mess. So let's FOIL out this x minus 2 and this negative 3 minus 2x. So let's see, it's going to give us a negative 3x minus 2x squared plus a 6 plus 4x. Then distributing this minus sign through, we're going to have minus 4 plus 3x plus an x squared all over an x minus 2 quantity squared. Let's see what happens here. We have a negative 2x squared and an x squared. That's a negative x squared. This minus 3x and this plus 3x, those are gone. We have a plus 4x and a plus 2 all over x minus 2 quantity squared. And that's it. If we could factor this, we would, but there is no way to multiply two things to get 2 that add up to be a 4. So we're done right here. That is the derivative. Right there. Notice I check off up here. That just lets me know that I've picked up everything, that I haven't left a term off. You don't have to do that unless you want to. Make sure that you don't forget anything either. All right, look at number 2. Find all the derivatives for this function. All of them. So let's find f prime, and we just run on through using our polynomial or power rule. So 5 down, that's 40 x to the 4th plus 4 times 7, 28 x to the 3rd minus 9x squared minus a 24x plus a 15. That's the first derivative. We can find a second derivative. A second derivative is the derivative of the first derivative. So we just keep going here. Do a derivative. That's 4 times 40, 160x cubed plus 28 times 3 is 84. 60 and 24, yeah, 84 x squared. And we have minus an 18x minus a 24. There is a third derivative. 3 times 160, that's 480x squared plus 2 times 84, 168x minus an 18. Fourth derivative. There is a fourth one. All right, but after we start writing all these tick marks, it starts getting hard to count them all. So once we get to the fourth one, then we'll put it up here in parentheses. So this is the fourth derivative. 2 times 480 is 960 plus 168. Fifth derivative is just 960. Sixth derivative, the derivative of this constant is 0. seventh derivative, still 0. And as a matter of fact, every derivative after this would be equal to 0. So instead of continuing to write this out, right here, once you get that constant one, then every derivative after that, so the nth derivative is equal to 0 from the sixth derivative on, n greater than or equal to 6. All right? Now, I have some hints on some of your, homework. Implement your learning, 15 to 21. The directions say find dy dx and support your answer graphically. So I'm going to kind of do an example over here as I describe to what's going on so that you can kind of understand what we're asking you to do. So here's the example I want to take a look at. They give you y equals x squared. That's given. You find the derivative by yourself. dy dx, using our power rule, that's 2x. All right? Now, in y1, you're going to put the given function of f of x. So, y1, you put your given function of f of x, which is x squared. And you're going to turn that off. So, on a calculator, we're going to put this in, x squared. And then, see how that equal sign's highlighted? We're going to arrow back over on top of it. And, oops, I went too far. Hit enter. And now, see, it's not highlighted. So it's accessible. It's not going to graph. So that's your y1. y2, you're going to leave this one on. And in y2, you're going to do d dx of y1 at x equals x. That lets your calculator find the derivative. This says calculator find the derivative. So we're going to type in d dx of y1 at x equals x. That finds the derivative at every point. Okay, again, to find this, you can go to alpha f2, and then the third one down, and derive. And then we just fill in these boxes. So d dx of y1, we're going to get y1 from alpha f4, y1, at x equals x. And notice I left that one on. Leave that one on. y3, you want this one on as well. And you are going to put in your answer that you got for f prime, which is dy dx. So we're going to come down here in y3, and we're going to put in the answer that we figured out, which was 2x. So it looks like this, 2x. I just want to check my window here. Yeah, my window is standard viewing window. Now, when I graph these, and it's nicer on color because then you can see them going kind of right on top of each other. But you are looking for these two graphs to be exactly the same. So here's the first one. Oh, you know what? Oh, I'm going to show you something else. I'm sorry, I stopped it. I hit on and I stopped it. So go to y equals, and let's come down here to this 2x one. And if you have color, you're fine. But if you don't have color, go back over here and just all the way over there and enter once. And see how it made that line thicker? All right, now graph. So here's the first one. This is your calculator figuring out the derivative. And there's the second one. And the reason I made it thicker, did you see it? You could see it graph right on top. Right on top. And that's what you're looking for, is that these two graphs should be exactly the same. Okay, if I went pretty fast here, feel free to rewind the video and pause it and that type of thing as you go along to make sure that your calculator is set up the same way. Please don't just watch me do this. You have to practice it. You have to do it yourself. Thank you very much. Please join us on page 8. Oh, no, page 4. Sorry.